All right, now I'm going to go through with you all your activities that you are going to do pertaining to meiosis and the meiosis connection to inheritance for this unit. Sound good? So we're going to start off with our genes and alleles activity. So in this activity, you are looking at two sheep, a biological female sheep with light fur or light wool, I should say, and no horns, so polled, and then a biological male sheep that has black wool and horns, okay? And so you're going to work through this example with your lab partners, keeping in mind that the light wool color trait is dominant, and the polled trait, meaning no horns trait, is also dominant, okay? So your discussion questions are going to go over what phenotype is the male versus the female, what's the genotype of the male versus the female, keeping in mind that we know for a fact, just because I'm telling you right now, that the female sheep is heterozygous for both traits. After answering those couple of questions, you're then going to move on to practicing developing Punnett squares, both monohybrid crosses and dihybrid crosses. So starting with our monohybrid cross, we have our two sheep here, right? And so the way that you set up a Punnett square is you just pull out the alleles that pertain to each individual and line them up along the exterior of your Punnett square. So first we're looking at wool color, right? So the wool color of our female sheep we can put up top, and the wool color of our male sheep we can put along the side. All right, so in this example, we were told that the female sheep was heterozygous. So that would mean for the wool color genes that would go for the female, we would have a big A and a little a. And then for the wool color of the male, we know that it is recessive. The black wool trait is recessive, and so therefore we know that along the sides we would have little a, little a. Sound good? Okay. Then you're going to be asked to calculate that genotypic and phenotypic ratios for your sheep. All right, so the genotypic ratio is just looking at the ratio within the offspring, comparing the AA, so the big A, little a's ratios to the ratio of little a to the ratio of big A. So that's genotypic, whereas phenotypic is then interpreting those genotypes and finding the ratios of sheep in the offspring that would have either light wool or black wool. So next, after you practice with your monohybrid cross, you're going to go through and practice a dihybrid cross. So dihybrid crosses involve looking at two traits. So di meaning two, hybrid meaning putting together. So putting two traits together. Sound good? So we're looking at that horde versus polled gene as well as our wool color gene all together. So starting with what I have in this example is a white polled male sheep. This is different than what you have in your example. So this is just an example to show you how to set this up, because this kind of dihybrid cross Punnett square can be a little confusing for people that haven't seen it before. So starting with that male sheep, right? We know that the male sheep, because I'm telling you right now, and you will have plenty of information to set up your own hybrid cross, don't worry. But the male sheep in this example is big A, big B, little b, purely heterozygous for both traits. So the way that you set up a dihybrid Punnett square is to use the FOIL method. I don't know if you remember that from your algebra days, but basically FOIL stands for first to first, outside to outside, inside to inside, and last to last. So starting with first to first, we have our big A and our big B. All right, so that's going to be the first thing that we put on our dihybrid cross. Then we do outside to outside, so that would be big A, little b. Then we have inside to inside, which is our little a, big B. And then we have last to last. Sound good? And then we know that the female sheep has the exact same genotype, so off the bat we can know really quickly that it's going to be set up the exact same way as the male sheep in this one example. Okay? And so just running through this example with you all really fast so you can see how this would go, right? Just like how we do our normal monohybrid Punnett square, you fill in the boxes with what you have, right? So tracing down the line, so looking up here where we have AB, we can just fill in all this column now with AB, right? So let's go ahead and do that, AB, AB. And then here we can just fill in with the big A, little b all the way down there. And so filling that in, and then the same for these guys, right? And then you backfill by filling in now your rows, right? So we know that where these spaces are, we're going to put in the stuff for the rows, right? All along the way in these blanks, we're gonna have big A, big B. All along the way for the second row, we're gonna have big A, little b, and so on. So your dihybrid Punnett square for this cross would look something like this, okay? And so looking at our genotypic ratio versus our phenotypic ratio, if we want to look at our genotypic ratio, we can use some color coding to help us out to find where all of the similar or the same genotypes are, right? So I'll go ahead and do that for you nice and fast. All right, so I've color-coded the pink. Those are our big A, big B, little b's. And then the reds are big A, big B, and so on. All right, so hopefully that helps with that genotypic ratio. So we can see here that we have 4 of these guys. We have 2 of these guys. We have 2 of these guys. And so we can see all of this information here. And so we can use this to then build our phenotypic ratios, right? So all of these guys put together all have the same phenotype, which is white and polled. We know this because white is dominant and all of these have at least one big A, and all of these have at least one big B, and for the polled trait, B, the big B is dominant, and that is the polled trait, right? So that, counting all those up, would result in 9 white sheep with polled, meaning no horns. If we wanted to then look at our white and horned, so that would mean that we have to have at least one big A and all little B's. We can count those guys up here. So we have 2 of these guys, 1 of those, and no others, right? So that's 3 white and horned. And then here for black and polled, we have to have black wool, you must be recessive, homozygous recessive for the wool color trait. And to be polled, you must have at least one big B. And so I only see 3 of those guys on the screen here. So that's 3 of those. And then last but not least, we have a pure homozygous recessive sheep for both traits, and that would be black and horned. So all little A's, all little B's. And you know what? I only see 1 of those here. So there you go. So our phenotypic ratio would be 9:3 to 3:1. Whereas our genotypic ratio, you can use the colors on the screen to help you determine that genotypic ratio. So next, you're going to carry out your own dihybrid cross using the sheep that you have provided for you in your Canvas course module.